Hi, my name is Matthew Woodford. I've been in the motor industry for 45 years, and I want to give some of my benefits, some of the experience that's been given to me. I want to pass that on to other people. So what I want to talk about today is one of my favorite pieces of software in the quality system arsenal is FMEA. I want to take the mystery or the secrecy out of what is an FMEA, what it can do for you, and how it can make you as a person a stronger engineer, technician. When you use this tool correctly, it empowers you. So, an FMEA. We've got various types of FMEAs. We can have a design FMEA. That is where the designer who's designing the product wants to test the robustness of his design. He wants to see if this aspect of this design fails, does it put a person's life at risk? Should this fail, does it make the end user disgruntled because it takes away primary function of the design, of the purpose of the part that is being designed and developed? If he's done a good design FMEA, we can then go and look at our machine FMEA. Or prior to that, our process FMEA. Our process FMEA, same strategy as a design FMEA, but we use it to analyze our process of manufacture. From our process of manufacture, we can have outputs that would go to things like control plans, it would go to preventive maintenance, it would go to machine tender documents. There would be outcomes, which we'll talk about in a bit. I'm not teaching FMEA. I want to get you to understand the benefits and what the basis of an FMEA is. So we can have many varied types of FMEAs, reverse FMEA, systems FMEA, but at the end of the day, it is an FMEA, which stands for your failure mode and the effect that it has, and we analyze it. So FMEA, failure mode and effects analysis. We all do an FMEA without even thinking. There is no secrecy and no mystery to an FMEA. It is a risk analysis tool. It's something we use in a structured format when we do an FMEA that takes us through specific steps where we break those steps down and we test the outputs. We do that in our everyday life without even thinking. If you're taking a trip, 1,000-kilometer journey, you're doing a lovely road trip, you've planned this trip for a while, automatically you're thinking, you're not thinking, but it's there in your subconscious. What can go wrong? Has my car been serviced? When did it last get its service interval? Do I need to get another one before I go? Why? I'm thinking of the failure. My car's going to break down along the way. That's not going to make my trip pleasant. Just send it into the dealer, make sure it's got its latest service. Make sure the oil level is topped up. Is my radiator water leaking? Is it topped up? Have I got the right mixture for my antifreeze? What are my tires like? I'm doing a long journey. If I've only got 800 kilometers of tire wear left, I better put some new tires on because I've got to make that journey there and I want to get back without failure. So automatically we are already thinking, this is my purpose, this is my process. Pack the car, get in the car, fill it with fuel, drive to my destination. What can go wrong during my drive to my destination? That is an FMEA. In a simplistic, basic approach, you are examining the functions, the steps of your journey to your destination, and you're thinking in your mind automatically, what can go wrong? The car could break down, I could have a puncture, my tires might go flat. Do I have a spare wheel? Is my spare tire in good condition? I better check it before we leave. We're already thinking of the basic steps of the journey. We're thinking of the expected outcomes. We're seeing what do we think could go wrong, and we're putting checks in place to prevent that event from happening. That's an FMEA. In the automotive industry and the manufacturing industry, we take that basic concept and we're putting it into a structured process. By having structure, we are all applying the FMEA in the same manner. We've not got Jim's version and Dave's version and Fred's version is different still. And when we look at it, we think, gee, what am I reading? We have a structured approach that anyone in the automotive industry can look at anyone else's FMEA and we know what we're looking at. Secondly, with a structure, it takes us through a unique set of steps. By doing those, following those progressions in those steps, we can question each one of them. We need to understand what they are asking us. For example, we need to be able to analyze a process flow. This is my process. I'm going from the first operation to the second operation to the third to the fourth to the fifth. This is what I foresee, because we want to do an FMEA before we spend any serious capital money. Because depending upon the outcomes of that FMEA, it could change your tender document to your potential machine supplier. This is one of the big benefits out of getting an FMEA right and not just putting ticks in boxes. We want to be able to understand the process that we are planning. When we have each of those steps, we're going to take that first step, followed by the second and the third until we get to the end, and we're going to break those steps down into functions. What happens in this process step? What have I designed my process to do? We have inputs to a process. Those inputs, if you're into it, is your 5 M's: man, machine, material, method, Mother Nature. All those inputs go into your method. And if you're baking a cake and you've got the right mixture and the right sequence of adding the elements, we expect an outcome. The outcome is a nice, juicy, succulent cake that's not overcooked, not tough, not dry, not crumbly, unless we're designing a crumble. But that would be in your design FMEA. So we've got our process FMEA. We've broken down that step into inputs and expected outputs. We expect to get to our destination in our car trip. In our process, we expect this output, that output. We identify. If we can break down those functions into elements and expected outcomes, now we can test those outcomes. We just ask the familiar question, well, what can go wrong? What if I don't get that? That's my failure mode. Who's been to B&Bs, bed and breakfast hotels? We order a slice of toast, or we go to the counter and we put our white slice of toast in. Yeah, I want some nice golden brown toast to go with my breakfast. I put it in at the top. The toaster whirls and clicks and clunks, and eventually it comes out the bottom. It's still white. I wanted golden toast. So I put it in the top again for a second run. Only this time it comes out burnt at the bottom. Oh, I don't want that. I put it in the bin, wasted piece of bread, unnecessary expense, gone down the drain. My process, or the process designed to make my golden brown toast, didn't work. That is the failure mode. The expected outcome of putting in your piece of bread at the top is a nice piece of golden toast at the bottom. That is my expected outcome. What can go wrong? It's not golden brown. I could say there are two failures. It's burnt and black, or it was the same color as it went in at the top. It's not cooked. So those are failure modes. What we need to do next for each of the failure modes that we have identified in our process is challenge it and say, what made it not get cooked? Why did it get burnt? What controls do I need in place to make sure that this doesn't happen? Because every time it happens, we're throwing a slice of bread away if it's burnt. So I have to think, this is my process, this is my expected outcome, but I'm not getting it. That's my failure mode. Now, what can I put in place to make sure I don't get that failure mode? In the case of our piece of toast, we have an element that heats it. How hot does that element need to be? We have a conveyor that takes the piece of bread past the heated elements. How fast or how slow does that conveyor system need to be? If it's too fast, it's gone past the elements, it's only licked a little bit of heat, it comes out just like a piece of white bread. However, if it's too slow and the element's too hot, it comes out burnt. So we have already identified two controls that we need in our process to prevent the process from failing. If I can control the temperature of the element, if I can control the speed of that conveyor, and if those are controlled in that function, that machine, I should have a high probability that I get my expected outcome. This is all we're doing with an FMEA. Identifying those potential failures of each function or element in your process, looking for ways to ensure that that failure doesn't occur by putting in controls in your machine to prevent this from happening. I've been buying machines off in Japan or lots of other countries, but this one specific one was a rotary transfer machine. If you are reading this or listening to this, you should understand a little bit about manufacturing. The rotary transfer machine needed some special tool change procedures with big heavy cutters coming on and off. And while I was there, I just suddenly thought, can I break this machine while they're doing a change to the tooling? So I said to my Japanese colleagues, my engineers there, I said, while you're taking that cutter off, if I pressed index table on the control panel, will this table index? They looked at me horrified. And they said, but Mr. Woodford, you wouldn't do this. No, that is silly, dangerous. I know it's dangerous. But if I press that rotate, will the table rotate? They go away and they have their little talk and chatter and they come back. Yes, Mr. Woodford, it would rotate. Okay, so there's one of the controls I want put in place in your machine, not to protect the integrity of the part, but to protect the safety of the operator, of the setter. That is also a necessary element in an FMEA. So this team went away, they came back with some new PLC logic for the controller, and they looked at me and smiled and say, you can press the button now. I pressed that button and the rotary table did not turn. Good. This is what we need to do. We have a thing now developing in FMEAs called reverse FMEA. Reverse FMEA is something that can mean different things to different customers. Ford, General Motors, Volkswagen, they all have different understandings of reverse FMEA. But a reverse FMEA is not, I've got my production line, now I better do the FMEA. Too late. The FMEA is done before you buy the machine, because the outputs of that FMEA, the controls that you want in place, could be part of your tender documentation to your potential machine supplier. You're telling that machine supplier, I've identified in my process FMEA these specific possible failures that could occur that will create a non-conforming part. You need to show me in your machine FMEA, because now I'm giving you the outputs of my process FMEA that concern your machine controls. You need to make sure that you address those. And I want to see it in your machine FMEA. So they will take those outputs from my process FMEA, look at them into their machine design, and build them into their control systems. A reverse FMEA, I'm an ex-Ford guy for many years. They want you to try, once your process is in, it's gone through all the launch controls, you're into series production, they would like to come and have a look 12 months down the line and say, what have you done to try and improve your process, robustness. I want to see that you have got a plan that says, let's look at, set your plan up, priority machines. Which are your machines that probably are your constraints, your bottlenecks, your machines with the most significant characteristics? What have I done to test to see if that machine could fail, if it could produce a bad part? I've got all the controls that I came up with in my FMEA in place. Got my control plan that gives me all the detections of a possible failure getting through. I can detect it. They now want to say, okay, do some reverse FMEA. What else could you do to that machine that you haven't thought of during your FMEA? What happens if I put the part in upside down? What happens if the tool changer puts the wrong tool in the machine? Can I load the part back to front and would it break the machine? Would the machine cycle? We all might sit there and say, don't be crazy, don't do things like that, don't tempt Providence. We have a thing, as we all are aware, in the manufacturing and basically the motor industry, is Murphy's Law. If it can happen, it will happen one day. We need to test it before it happens. So for Ford, reverse FMEA is, have I tried to make this process, this particular operation fail? This was what I tried to do. This is what we did. This is what was the result. Document it, keep it. That is part of your evidence. During audits, they ask you, what have you done with regards to reverse FMEA? This is our plan. We're starting with this machine. Once every second month, we're going to take the next machine and the machine after that. And we've set this priority up because of whatever reason you've decided your priority is. And you're trying to do stupid things and making sure that your machine will not allow it to happen. That is part of reverse FMEA. For other customer-specific requirements, your reverse FMEA could be driven by your quality matrix, your data from your quality feedback, from warranty information, from customer complaints, from G8Ds. We've got these quality issues. Why didn't my FMEA prevent me from these happening? Go back to your FMEA. Go and do your own audit on your FMEA that says, we said if this could happen, but we said we've got these things in place. It shouldn't have happened. But here it is, it's happened. I also had a control plan that says, but if it does happen, this is how I'm going to detect it and protect my customer. He didn't get protected. If he did, guess what? We wouldn't have a system called 8D. We have 8Ds because our customer has received a faulty part, a defect. So doing an FMEA is not going to guarantee that you have the most robust process ever, but it will take out that 99% of the possible failures if you do an FMEA properly and you don't just tick the box. An FMEA is there to save you time and money in a process. If you have to change your machinery or your process or your equipment after you've already bought it and installed it, it's going to delay your project, it's going to put time penalties on you, or you will have to hire new and additional resources to overcome the time penalties. Either way, it's going to cost you. Do the FMEA before you commit your capital expenditure and you will save plenty of money. As a person, you want to get ahead, you want to learn. An FMEA is an encyclopedia of knowledge. If your FMEA is a good, solid FMEA, you want to learn about this process, you want to learn about the company you're in, ask to have a look at the FMEA, read it, understand it, challenge it. FMEAs are encyclopedias of knowledge. It's there for everyone to learn. I hope you understood what I believe is one of the best structured systems in manufacturing. If you're in process engineering, project engineering, I lived and breathed FMEAs. They were exciting for me. It was an opportunity to continue my learning program. Hope you enjoyed this. I'll talk to you later.